Hello and welcome to your Physics Buddy. Today we are going to explore the fascinating relationship between pressure and volume in gases and how this fundamental law affects our everyday life.
Pressure gauge, or animated particles hitting walls with force arrows.
Before we deep dive into Boyle's law, let us quickly define what gas is. Gas laws are scientific principles that describe the behavior of gases by looking at the relationship between their physical properties. The key properties we'll be focusing on today are pressure and volume and temperature. Boyle's law is one of the most important of these fundamental laws. The law we are studying is named after the Irish natural philosopher Robert Boyle, who lived from 1627 to 1691. He is a true pioneer, known for his experimental approach in science and his groundbreaking work, Skeptical Chemist. The core concept of Boyle's law is nothing but inverse relationship. So, what exactly is Boyle's law? It states that for a fixed amount of gas at a constant temperature, pressure and volume are inversely proportional. In simple terms, this means as the pressure of the gas increases, its volume decreases, and vice versa. It's crucial to remember that these law only holds true when the temperature of the gas remains constant. We can express the Boyle's law with this simple mathematical formula. P1V1 is equals to P2V2. P1 and V1 are the initial volume and pressure, whereas P2 and V2 represents the final pressure and volume. This equation is incredibly useful for calculating how a gas volume or a pressure will change under certain conditions. Looking at this graph, we can clearly visualize the way inverse relation. As we move along the curve, you can see that when the pressure of the y-axis is high, the volume of the x-axis is low. Similarly, when the volume of the x-axis is high, pressure is low. So this shows the inverse relationship. This hyperbolic shape is the signature of an inverse proportion. You can experience Boyle's law with a simple demonstration. Take a syringe and block the tip of with your finger. As you push the plunger in, you are decreasing the volume of the air trapped inside. What happens? It becomes harder to push. That's because you are increasing the pressure of the air inside the syringe, which is resisting your push. Along with the Boyle's law, we have already discussed what is the kinetic theory of matter. Kinetic theory is specifically defined for solids, liquids, and gases, but it primarily works for gases much. We have already seen this. I'll add the link in the video. You can check it out there. Also, you guys already know that how changing states of matters takes place. What are the phenomena related to it? And this is something that you guys need to remember every time when you're talking about gases. Boyle's law isn't just a theoretical concept. It's happening all around us. For example, when you breathe in, your diaphragm contracts, increasing the volume of your lungs, which lowers the pressure and pulls air in. Similarly, scuba divers must be aware of Boyle's law because as they descend, the decreasing water pressure causes the air in their lungs to expand, which is why they must exhale on the way up. It's also why you can't overinflate a balloon or a tire. The pressure inside is counteracting the pressure up from the outside. Let's put this into practice with a quick problem. Imagine a gas having a volume of 10 liters at a pressure of 1.5 atm. If we increase the pressure to 3 atm, what is the new volume? So in order to solve this problem, we'll be using Boyle's equation. What Boyle's equation is? Boyle's equation says P1V1 is equals to P2V2. So if we rearrange this equation for finding V2, we'll get P1V1 by P2 is nothing but V2. Let us substitute the values of whatever we have here. So initial pressure was supposed to be 1.5 atm, initial volume was supposed to be 10 liters, and final the pressure changes to 3 atms. If we reduce the relation and we solve the values, we'll get that volume of the gas becomes 5 liters. So this is how Boyle's law actually affecting the volume of the container of the gas when the pressure changes. So as you can see, doubling the pressure halves the volume. This is what it shows inverse square law. To summarize, remember these key points about Boyle's law. It was discovered by Robert Boyle. It describes an inverse relationship between pressure and volume. It only applies when temperature is constant. That is the most important thing. Its formula is P1V1 is equals to P2V2. It's a principle that governs many real world phenomena, from breathing to scuba diving. Thank you for your attention, guys. I'm happy to answer any of the question related to the given topic. And in case if you want me to explain some other topic, just write it down in the comment box.